Okay, number 45, inside one petal of the four petal rows, R equals a cosine of 2 theta. Now, you got to be careful on this. You just can't say it's one. It's just going to go from 0. We know the whole, if we graph it, it's going to be sketched from 0 to 2 pi. All right, that will get us the whole four petal rows. You can try that on your calculator of R cosine of 2 theta. But it starts here, so it's going to go like this. These things are kind of strange, so you got to kind of watch the way these things go. It goes like this, and it goes around like that, goes up like that, around like that, around like that, around like that. I tried just a few checkpoints, but I really checked it. I put it on my calculator, traced it. So you see that you just can't go, if you try to find the area from 0 to pi over 4, that's going to be kind of strange. All right, or from 0 to pi over 4, you know how it works, pi over 2, it's going to go all the way around like this. So basically the easiest way to do it is just find the total area and then just divide it by 4. That's the easiest way to do it. Okay? So one petal is 1/4 the area. So that's going to be 1/4 the integral from 0 to 2 pi of 1/2 the cosine of 2 theta squared d theta. So I'll just put in my formula. This is my R. This is my formula from alpha to beta. So I'm going to go from 0 to 2 pi, 1/2 this. In other words, don't think about going from 0 to pi over 2, I should say. Okay, this might be pi over 4, pi over 2, 3 pi over 2, pi, like that, and then we've got more of it, the other half of the thing. Okay, the way it works. So that's a little bit harder to deal with. So just take the area of the whole thing and then just divide by 4. All right? Don't get tricked into trying to do something fancy. Okay. So, let's see here. So that's 1/4. There's my 1/2 from my formula, R squared. Okay? So 1/4 the area. I can take 1/2 out, I get 1/8, and I've got this. Now, again, this is of the same, this is the reduction formula. All right? It's going to be 1 plus the cosine of 2 theta. In this case, theta is 2 theta, so 2 times 2 is 4 theta over 2. Same idea, though. Same thing. Okay, so again, we use that same formula. Page 565, the same reduction formula. And then we break this up and we take another 2 out. So now we've got a 1/16 out in front, and we've got 1 plus the cosine of 4 theta. Now the same respect, if I'm going to use a chain rule, I need the derivative of 4 theta, which is 4. I put a 4 here, I got to put a 1/4 in front. So same idea. So this is kind of like a U substitution adjustment. Okay? But we're not actually doing a U substitution. It takes a little bit, it takes extra steps to write all that out. So we're just going to make this 4 and 1/4. So now we've got it. Okay, so the antiderivative of 1, we got the 1/16 out in front. The antiderivative of 1 is theta. And then the antiderivative, this will be 1/4. And the antiderivative of the cosine of 4 theta times 4 is the sine of 4 theta. And you can take the derivative. That's the derivative of the sine of 4 theta. Cosine of 4 theta times 4. See, so it checks out. Chain rule. Okay, we're going to evaluate that from 0 to 2 pi and 1/16 times that. Well, I'll put the 2 pi in here. If I put 2 pi in here, all right, that's 8 pi. It doesn't matter. Any multiple pi is going to be 0, so it's going to be 0. And if I put 0 again here, I get 0, and the sign is 0, 0. So all I have is 1/16 of 2 pi, which is pi over 8. So that wasn't too bad. Okay, hope that helps.